and we can continue with this really nice lesson. It's the next lesson in the series of the lessons about numerical problems. What we'll see today is mainly percentages, and we'll see how we use percentages to answer real questions in EPSO. What we do actually now is not EPSO questions, but we do some basic methods or methodology that is very helpful when you go to the real exam and try to answer real questions. We'll see later how the real questions are. We'll see which is the best way to deal with the questions, and we'll see very carefully what is the way to succeed in the exam. So let's start with the percentage. So don't confuse a percentage increase by the percentage of an original number. This is very important. So if I were to find 20% of the number 50, it is you multiply 50 by 20%. So you can say also 50 times 0.2. What you get from this operation is actually 10. So to find the percentage of a number, you multiply the number by the percentage. It's a totally different thing to find the percentage increase. So to have an increase, it means that I have an initial value and then have a final value. So the percentage increase change is, if we have increase, it means I have a lower value here and a larger value finally. So the percentage increase is the final value minus the initial value divided by the initial value times 100, and then you put the symbol percent. So for example, you have a price that goes from 20 to 30. What is the percentage increase? This is the initial value, this is the final value. If you look at the formula here, this is the final value, that's 30, minus the initial value, that's 20, divided by the initial value, that's 20, times 100, and the whole thing percent. How much is that? 30 minus 20 is 10. 10 over 20 is half, times 100%. It means exactly 50%. It's very logical, because if you go from 20 to 30, it's 20 plus 10 to go to 30, and the increase, so the number 10, is 50% of 20. So you have 100% initially plus this one, that's 50%, and the final thing is 150%. Since you went from 100% to 150, the change is 50%, and in this way everything goes into place. So if you want to find the part of something, you multiply the total by the percentage, and then you take the part. If you want to change a fraction into a percentage, for example, 25%, 25 over 100, this is exactly 25%. Now, if you divide 25 by 100, you will get exactly, with a calculator, you will get 0.25. So what's the way to change this into a percentage? You multiply by 100, and what you have is 25%. So the fraction 25 over 100, that's exactly the same as the fraction 1 over 5. If you simplify that, gives you exactly 25%. So these three expressions here are absolutely equivalent. Um, so what happens if you have a percentage decrease now? Well, we start with an initial value and we go to a final value, but the final value is actually smaller than the initial value. Then how do you find the percentage decrease here? What you do is you take the initial value minus the final value over the initial value times 100. All this is percent. Now, be careful here because when we had increase, so when we had increase, we had here future value or final value minus initial value over initial value times 100%. But here that we have a percentage decrease, we have this formula. Why we do that? Because actually, imagine that you go from 100 to 130, so you have an increase of 30%, and the answer here will be that we have an increase of 30%. But if you go from, for example, from 100 to 80, then you have to subtract 100 minus 80 divided by the initial value, that's 100, and this is 20%. And actually, I have a decrease of 20%. If I kept the same thing here, so I got the initial value, the final value minus the initial value, I would get a minus. And I don't want to get a minus because the expression increase equals 30% and the expression decrease equals 20% are absolutely correct. I could say for this one that I have an increase of minus 20, but I don't want to confuse you with mathematics here. What we need is to have a very simple way of understanding the way that we must think in the exam. So let's see something that is a little strange. So I have some space here. Well, we have someone called, for example, John, and John plays in the stock market, so he buys some stock, and suppose that he bought the stock at 30 euros, and the stock went to 20 euros. So this was the initial value, and this is the final value maybe after 1 month, for example. So do we have a percentage increase here? Yes, we have a percentage increase, decrease. What is that? This is the initial value. So the percentage change is the initial value minus the final value divided by the initial value times 100 and the whole thing percent. So this is 30 minus 20, it's 10 divided by 30%. So this is about 33.3%. So what John says, he's a little naive actually, and says, oh, okay, we had a minus of 33.3%. We had a fall in the market, but now I'm expecting the market to go up by 33.3%. And now if it goes up by the same amount, it will go back to the previous value. Is that correct? So for example, if I have a stock and I lose 10% on that stock, and then I have a value 1, and then I have a value 2, and then it increases again by 10%. We have a value 3. So it falls by 10%, so you have a lower value here, and then it increases by 10%, so we have another value here that's larger than this. John believes that since it fell 10%, if it goes up 10%, it will go up to the old value. Is that correct? Let's see. Suppose that the value of the stock is 100. Minus 10%, the new value is 90. it increases by 10%. So 10% of 90 is 9. So it goes to 99. So no, it doesn't go up to the same amount. And also a more dramatic example is this. So you have the initial value is 100. We have a fall of 40%. It goes to 60. And then we have a rise of 40% again. So let's see, does it go back to the old value? So the stock was 100, after a fall of 40% became 60, and then it increases 40%. So what is the new amount? 40% of 60 is 24. 60 plus 24 is 84. Whoa, it's far away from 100. So even if the market goes up the same amount that fell before, the final value of the stock is not exactly the same as the original value. And as you see here, the more the fall, the more the distance from the original value after the market goes up by the same percentage. Um, this is all for now. This information is actually really important in the EPSO exam. Many questions, it may seem simple, easy, and maybe intuitively obvious, but this thing here appears in many questions in the exam. See you again soon. Thank you for listening. Bye bye.